Welcome to Tejas Statistics. Today we are learning about the cumulant generating function, which is very important for the BSc first year students and data science also. Cumulant generating function. Consider K1, K2 and Kr are the cumulants. Then Kx of t is equals to K1 into t, K2 into t square divided by 2 factorial and so on. Kr into t to the power of r divided by r factorial and so on. So this is the kx of t is equals to logarithm value of mx of t. If you apply logarithm to the mx of t, you will get the cumulant generating function. In general, the rth cumulant kr is to be obtained by expansion of coefficient of t to the power of r divided by r factorial. So mu1 dash into t plus mu2 dash into t square divided by 2 factorial and mu3 dash into t cube divided by 3 factorial and so on, minus 1 by 2 of mu1 dash into t plus mu2 dash into 3. This is the second power. Next, this is the third power and so on. Logarithm of 1 plus x is equals to x minus x square by 2 plus x cubed divided by 3 and so on. Excuse me. On comparing the coefficients of powers of t on both sides, we will get so k1 equals to coefficient of t to the power of 1 divided by 1 factorial equals to kx of t is equals to mu1 dash. So that is mean. Similarly, k2 equals to coefficient of t square is equals to kx of t is equals to mu2 dash minus mu1 dash whole square. So this will very important. This is called the variance. K2 is called variance. This is equals to the mu2. Next, K3 is equals to coefficient of t cube divided by 3 factorial. In kx of t is equals to mu3 dash minus 3 into mu2 dash into mu1 dash plus 2 mu1 dash whole to the power of 3. So K3 is equals to like this. Next, the coefficient of value, if we compare coefficient of t to the power of 4 divided by 4 factorial in kx of t, mu4 dash value directly you can write on simplification, that is mu4 minus 3 into mu2 dash minus mu1 dash whole square whole to the power of 2. That always simplified by the k4 is equals to mu4 minus 3 mu2 whole square. So this can be called the mu4 equals to k4 plus 3k2 square. So movements from the cumulants we can observe here, that is mean equals to k1 and variance equals to mu2 equals to k2 and mu3 equals to k3, mu4 equals to not directly equals to k4, that is mu4 is equals to k4 plus mu4 plus 3k2 square. Okay, so that is very important. mu4 is equals to k2 plus 3 into k4 plus k3 in 3 into k2 square. Next, properties of cumulant generating function. mu4 is equals to k4 plus 3 into k2 square. Properties of cumulant generating function is equals to additive property of CGF. The CGF of sum of n independent random variables is equals to the sum of their respective CGFs, cumulant generating functions. As you can see, the sum, if x1, x2, x3 and so on xn are n independent random variables, then k x1 plus x2 plus x3 and so on xn of t is equals to k x1 of t plus k x2 of t and so on k xn of t. So this is can be proved by if x1, x2, x3 and so on xn n independent random variables, then from additive property of MGF this is the mx of t is equals to mx1 plus x2 plus x3 and so on xn, that is equals to mx of t into mx2 of t into and so on mxn of t. So apply logarithm on both sides, you will get the addition to these values. This can be proved very easily. The effect of change of also on the cumulant generating function you can see. The CGF is not independent of shifting of origin and scale. Let u equals to x minus a divided by h. The CGF formula logarithm value of mu of t. So we here e of e to the power of t u, since mx of t formula expected value of e to the power of tx. As you can see, substitute u value over here, then you will get the function like this. Then here e to the power of minus ta by h is a constant, putting outside and applying logarithm to that, and both are in multiplication, you can apply the formula also. This will become logarithm value of mx of t divided by h. So CGF is not independent of shifting the scale and origin also. Next, properties of cumulant generating function, additive property we already seen, and the function also we can able to calculate by derivating d to the power of r divided by dt to the power of r kx of t 1, where t equals to 0. If you substitute, then you will get the answers. Okay, next effect of change of already we done. Next characteristic function we are going to discuss in the next session. Up to this we have the properties and the definitions of a cumulant generating function. Thank you.